Well, hello there, everyone. James Hilliard here. Welcome to our podcast. This is part of a series of conversations with the team at CBT. Their team is dedicated on bridging the gap between information and operational technology. Today, we are discussing condition monitoring and predictive maintenance. My guest on board here is Preston Johnson. He is the Senior Solutions Manager for IT, OT, Industrial Operations and Maintenance there at CBT. So here's what we've got on the docket for about 10 or 15 minutes here today. A couple things we're going to look at. One, kind of that holistic view of condition monitoring, predictive maintenance, why it's important. We'll probably touch on a little bit of ROI. We'll talk about developing really the solid strategy, right? So you can support open architecture systems today and also tomorrow, because that's important. And then we're going to touch on this concept, these digital twins, right? The virtual representation of physical assets or processes. We'll talk about that and how that plays into this whole condition monitoring and predictive maintenance space. So Preston, that's what we're going to be covering here for the next 10 or 15 minutes. I'm glad to have you on board.
Well, thank you, James. It's a pleasure to be here. These are really my favorite topics, and I've been working in this space for well over 2 years. From developing condition monitoring and predictive maintenance products to predictive maintenance strategy consulting, and more recently, deploying open and holistic systems for condition monitoring and predictive maintenance.
Well, let's get into kind of the idea here of why condition monitoring, why the predictive maintenance, why have these tools become so important to teams these days?
Well, James, in asset-intensive industries, such as chemicals, oil and gas, power generation, mining, and even food, beverage, and automotive, our physical assets like our pumps, our turbines, our heat exchangers, generators, fans, kilns, and mining, they perform the work that produce our products. The performance of those assets are paramount to production output, to production quality, to production costs, and even to the safety of our workers. So really, if the equipment performs well, we get a lot of product. So from a return on investment perspective, our well-performing equipment is reliable, and you can count on it to produce your products. Those well-performing assets or equipment produce actually higher quality product at lower energy costs and operate more safely. With condition monitoring and predictive maintenance, maintenance is less expensive and less interruptive to production. All said, revenue increases as equipment produces more product. Costs such as energy and maintenance and labor are reduced with reliable equipment. Environmental costs are reduced because we use less energy and we waste less material. Safety increases as equipment is more reliable and predictable in its operation. And what's really cool is all this can be measured and compared to industry best practices. For example, in best practice cases for good condition monitoring and predictive maintenance, we usually get 2 to 3 months of lead time to plan and schedule all of our maintenance activities, which saves us expedite costs, overtime labor, and surprise shutdowns. In best practice, 90% of the work that we do to maintain and operate our equipment is scheduled after it's been planned at least 3 weeks ahead of time. And only 10% of the work that we do, or even less, better yet less, sneaks up on us and causes that unscheduled downtime. So really the return on investment of condition monitoring and predictive maintenance is improving revenue because we produce more. It lowers our maintenance and our operational costs. We use less energy, it's less expensive to maintain our equipment. And fundamentally, it increases the safety of our plant.
Every time I think about any technology that I talk to teams about, I also think about the people aspect here. And some surprise failure of something, and then people are in scramble mode. And sometimes when we're in scramble mode, we don't make the best decisions, or we could make a mistake, or we could miss a step. But the idea here of knowing, this turbine looks like it's on its last legs. We've got some bearing issues or what have you. So let's schedule the time and all that. You can just be so much more focused on what you're doing. You laid out again all the return on investment of having something here. So let me ask you this here in terms of industrial IoT. IoT, right? It's all these systems and monitors that we have to help us understand and gain that insight. How does the industrial IoT really help contribute building that predictive maintenance strategy side of it, and let teams really have a strategy, not just a reactionary something broke, got to fix it?
Yeah, so that's a great question, James. From a holistic view, we really need to see a big picture of our equipment, from not only the existing sensors that kind of come with the equipment that support the control system. The operators and the programmable logic controllers typically control the flow, the process, the pressure, the temperature, the speed, et cetera. Those sensors alone give us a good idea of the performance of the assets and of the equipment, but they're really not good predictors of when we need to perform maintenance. So we need more of a holistic view of the equipment. We need our maintenance to address the wear and the tear or the degradation of the equipment that's just natural in the operation. And if we don't address that wear and tear and that degradation, then the performance drops and ultimately production stops. So what we need to do is to be able to somehow detect and track that wear and tear so that we can understand the functional health of our equipment and plan mitigation of any unplanned stoppages. And there's where we start to add in the industrial IoT sensors like vibration and motor current and oil analysis, ultrasound, and even thermal imaging. And each of those sensors, they detect some, but perhaps not all, of the wear and tear defects that will likely cause our equipment to fail. And those defects can cause the asset to fail to perform its function and it stops working. So those IoT sensors, they catch that degradation of the equipment, they catch the patterns early so that we have the opportunity to plan and schedule the maintenance well ahead of the failure, typically months before a problem is really likely to cause us an unplanned outage. For example, vibration can detect defects in rotating equipment bearings, gearboxes, cavitation in pumps, unbalance in fans, and many more defects. On the other hand, oil analysis, adding to the pie, can help us detect viscosity breakdown, water in the oil, and other contaminants in the lifeblood of the machine. And motor current analysis can help us detect problems with the motor, like rotor bars and windings and the eccentricity, the air gap in the motor. So all of those together give us that holistic picture. And if we design and look at our IoT sensors from an open architecture perspective, that gives us the ability to mix and match across the vendors, to use best-in-class technology, to use what we already have in place so we don't have to replace it, and be able to expand and grow over time.
One of the things I mentioned at the top here was this idea of these digital twins. And obviously, having sensors in place is great, but the idea to be able to represent something in a virtual manner, representing that physical asset or process, how is that playing into this condition monitoring, the predictive maintenance space, these digital twins? To me, it just seems like a no-brainer. And it's finally one of those. Finally, we have this technology that we can use, right, to advance ourselves. Talk to me about that for a moment.
Yeah, so historically, in the condition monitoring space, the number one thing to do was use vibration to detect defects in equipment, and then use that vibration in of itself to tell us what kind of a maintenance. And that was sort of a siloed view of the equipment. What digital twins give us the ability to do is bring all of that holistic information together to help us manage our assets over their entire life cycle. Digital twins contain the performance specifications. How much flow should we expect from this pump? Digital twins include the likely degradation patterns and the failure modes of the equipment we might expect to see. They tell us what sensors we could use to detect those degradations and what the thresholds might be for those equipment. Digital twins help us keep track of the preventive and the predictive maintenance that we perform, keep track of records and costs, work procedures, work plans, and so forth. They keep track of the trend data from the control system and the trend data from all those industrial IoT sensors that we might add, so we can see how things are ebbing and flowing in our overall process. They help us even contain three-dimensional models and process and instrumentation diagrams so we can actually visualize and understand how to take apart a machine, how to put it back together. Digital twins really bring our predictive maintenance and our operations and our effort to keep our equipment up and running to life from this digital world. And going further, when we connect these digital twins to our workers in the field, we call them connected workers. That allows us to enable augmented work instructions, better digital workflow, so that the workers in the field are connected and they see all this information as they're performing their tasks. In sum, digital twins are the accumulation of all of the data, engineering specifications, procedures, three-dimensional drawings, and so forth, that give us that holistic view that allow us to be most predictive and plan ahead with our maintenance and our operations activities.
I appreciate it, Preston. A lot of stuff you went over here. Folks, I want to give you some contact information to reach out to the CBT team. And I can also tell you when you're on their website, which is cbtechinc.com, cbtechinc.com. Those connected workers are a couple of great little case studies I had a chance to read up on and see there. There are other archived webinars that are available, other podcasts in the series available as well. So again, cbtechinc.com. Also want to give you an email address if you want to get more information here, cbtinfo@cbtechinc.com. We'll do it one more time slowly. cbtinfo@cbtechinc.com. You can reach out and get more information. Send us a note there. I really do appreciate it, Preston. Thank you for joining us. Audience, appreciate you joining us as well. James Hilliard for the entire CBT team, and we do look forward to talking to you all down the road.